I'm Cherokee.
I'm Emma.
And I'm Violet, and we're Team Antipodes. So, please be aware of our model. It has over half a ton of full weight, so keep anything electronic or magnetic away from it.
Oh wait, it's not open up. Alright, so what is the most efficient method of ground transportation? So what makes ground transportation inefficient is rolling friction, or like if your car runs out of gas, it's like really hard to push. It's because of all the friction between like the car and the ground. And so that's basically why ground transportation is inefficient. So this is the equation for friction, and it's the force of friction is equal to the coefficient of friction, or like the slipperiness, times the normal force or the weight of the object. So these are three common technologies, and we calculated the friction force for all of them, and Maglevs are the only one with absolutely no friction. No friction.
So in a Maglev, there are three key components. There's the guidance system, the repulsion system, and the levitation system. The way the levitation system works is you have two magnets, one on the train and one on the track, that are the same polarity, and they repel each other, and that's what keeps the train floating above the track. And there's a control system, a laser control system, that keeps the train floating a certain distance away from the track, so that certain things like the weather or the amount of people on the train don't make it go down too low or go up too high. And there's also a guidance system that makes sure that as the train is moving along the track, it doesn't wobble too much on the track. And the way that works is there's another row of magnets along the side of the train and along the side of the track, and again it's the same polarity, repelling each other and pushing it away, and they're on each side, and so that's what keeps it steady. And there's also another laser control system that keeps it a certain distance away, so that when it's turning, it won't get into one of the tracks or something. Then there's also the propulsion system, which keeps the maglev going. And the way that works, there's an electromagnet on the train. And there's also a Hall effect sensor. And a Hall effect sensor measures the polarity of a magnet and also the strength of the magnet. And so what it does is, as it goes over the track, the magnets are on the track so that it alternates north-south, north-south. And so as the train goes along, the electromagnet on the train changes polarities with the help of the Hall effect sensor. And so as it's nearing the electromagnet will be north, and as it's nearing it south, it will attract it, but then when it gets over it, it will read south and repel it. And so it's attracting and repelling and attracting and repelling as it goes along the track. And that's how a maglev moves.
So the main question is, if maglevs are so efficient, why don't we see them everywhere? And that is because they're so expensive. They're double the cost of a bullet train, which puts them at $20 million per kilometer. And what makes them so expensive is cost, materials, and labor. So our proposal is that we make a hybrid maglev. What we would do is we put side wheels on the side of the maglev, which eliminates all the magnets and labor you need for guidance systems that are magnetic along the side. And you think this would cause a lot of friction, but it actually doesn't, because there's almost no weight on the side of the car. So here we have calculated the friction force for the side wheels, and as you can see, almost no weight, and so there's almost no force of friction. And then also here we have calculated the friction force for the bottom of the train. And one of the bad things about this is you have to sacrifice top speeds of 581 kilometers per hour, but I mean, we don't really need to go that fast, and we can still be efficient and go that fast. So how we're sharing with the world is that we have our blog, which will be open to the public in April at www.theonerobot.com. And our community is our world because efficient transportation would affect everyone. And bad transportation affects everyone's atmosphere. And here's some extras that we have and will be reviewing our project and giving us advice how to build our electromagnetic propulsion system. Oh, yes, that's one. Yay. And I'm just going to show you our maglev. Here's our side wheels right here, and as you see, it causes on lots of shut. And we will be building a propulsion system.
Any questions or? Yeah, of course. Okay. Stay over here.